Hello, this is Dr. Gardner. I'm preparing this tutorial to show you how to graph scientific data from the laboratory in Excel and how to prepare a correct graph so that anybody looking at your information can read it correctly and see that it's formatted properly, and it will help kind of guide you if you were to go into a profession and publish some of your information that you might collect. You would go ahead and format your graphs in a similar fashion. So first of all, let's start with an experiment from our laboratory. Let's consider when we were checking the counts per minute of a radioactive material that we were monitoring at every 10 centimeter distance intervals. Let's go ahead and consider what type of information we would have. So I'm going to go ahead and click here in my first cell. Now this column is going to be in cell A1, so column A, row 1. I'm going to go ahead and put a title in here, but I'm not going to graph the text from the titles. It's just so that the reader, if they look at my workbook, will know what data I've collected. So here I have distance from sample in centimeters. And if I want to resize my cell here so that it will contain the entire length of the text, you can go ahead and click on this line between column A and column B. You could left click, drag that over so you can resize. There's also some other menu options where you can size that specifically to a certain width number. But let's go ahead and look at column B. So in column B, I'm going to go ahead and graph my counts per minute. Now this is the counts from the Geiger counter that we're working with. So we're just going to use CPMs for counts per minute for the unit here. So you'll notice that in both cases I've listed a unit that I'm working with. I have centimeters, abbreviated lowercase cm here, and counts per minute from the Geiger counter in CPM. When we put our ANSYS titles on our graph, we'll definitely want to show those. Now when I'm preparing my Excel spreadsheet, I need to recognize that Excel will try to graph on the x-axis the first column. So since I want to put distance on the x-axis on my graph, I put distance in the first column. And so our first distance was 0 centimeters from the Geiger counter, and then my second distance was 10 centimeters from my Geiger counter. I can keep entering that, but I can also recognize if I have a lot of data to enter, I might want to go ahead and use a simple function to go ahead and quickly enter this data where it's just repeating every 10 centimeters. So I'm going to go ahead and click on cell A4, column A, row 4, and I'm going to type in my simple mathematical function. I'm going to say this cell will equal to, and I want it to be equal to the value from the cell above it. So that's going to be cell A3 here. So I'm going to just go ahead and left click on cell A3. You can see there's a flashing dotted line around that cell to indicate that I have selected that cell. Now I want to go ahead and perform a function with respect to the value from cell A3. So I'm going to say let's add 10 to that distance in centimeters to the value. So now it's 20. Now that may seem like more work than just typing 20 in, but if I'm going to do this multiple times, the nice thing about Excel is I can copy that cell. So I'm going to go ahead and left click on cell A4. I'm going to go ahead and copy, and I can either use the copy function from my home menu, or I can go ahead and use a keyboard shortcut. So for copying, I'm going to go ahead and hit Control-C to copy, and then I can go ahead as many data points down as I want. I can left click and drag my mouse button to select those cells, and I can hit Control-V to paste, or I could have used paste off of my menu up here. And so I want to go out to 100 centimeters, so I went ahead and pasted that in. So that would be faster, let's say if we were collecting large amounts of data, so we had hundreds of data points. That would be much faster to enter all that. So you notice it keeps incrementing down by one cell. So cell A12, if I look up here in the function box on it says that's referencing the cell above it. So we kept referencing just the cell above it, so that was very nice for incrementing the data down. That'll be quite useful for some types of experiments and some types of data that you're recording. Now, under the counts per minute, we collected that experimentally in the lab, or if you had any trouble with respect to collecting data in the lab, I might have provided this for you. So at 0 centimeters, we had 961 counts per minute. At 10 centimeters, we had 750 counts per minute. And at 20, we have 543, 344, 213, 148, 109, 78, 55, 43, and 29. So there's all of my data that I've entered for my distance and my counts per minute. Now if I would like to graph this, what I'm going to do is I'm going to left click on cell A2 where we have the 0 centimeters. I'm going to go ahead and hold my button down, my left mouse button, or on your pad on your laptops. I'm going to drag that cursor till I select all of the numerical data. You notice I did not select any of the text. So these boxes should only have numerical data when I'm graphing. If you had selected the titles, sometimes that cell won't always recognize those as numerical values. It will try to use them as numerical values rather than recognizing them as text, is what I mean to say. And so you may not graph it correctly. So I only selected the numerical values here. Now what I'm going to do is go up to my insert menu, and you can very easily add a chart. And so under my charts, you'll notice there's a lot of different charts available, but we want to, since this is continuous data in this case, we want to use a scatter chart. So I go ahead and pick scatter chart, and I make sure I am not connecting the dots, because what we want to use a trend line for our data. So right now we can see a preview of what our data might look like in its cell. So I go ahead and pick scatter chart. Here's my inserted chart that's been put into my workbook page. Now I find that it's kind of troublesome to try to adjust the chart so that it's right in a portion of the Excel spreadsheet so it's not covering your data, but you can also print it easily so that it's on a single page and you don't have part of the chart off the page. And so what I'd recommend is inserting this and move it to a separate workbook page in your Excel spreadsheet. So if you go up to the upper right hand corner of your chart, I would right click there, and you'll bring up a menu where you can go ahead and move the chart. So you see here it says move chart. So I'm going to click on move chart, and it's going to ask where do I want to move that to, and I want to put it on a new sheet. Okay, so it would default to label it as chart 1, but we might say this is radiation with distance, right, or counts per minute with distance. So there's the name of my new sheet. I can hit OK, and now this will move the chart to an entire new sheet in your workbook. And so you'll notice that the data that we had originally collected is in sheet 1. Now you could rename this. If I want to rename where my data is, I could label this as a radiation experiment. I can go ahead and click back at the radiation with distance, and I have the whole chart on that single page. Now the current version of Excel defaults, unfortunately, to have very small font sizes for the axes, so you might want to readjust those. So I would probably choose somewhere around 16. If we were professionally publishing this, we would want to go ahead and show our axes with respect to whatever font size the publisher that you would be publishing through is requesting. Okay, so I'm just going to default towards 16 because that'll be fairly easy to read here. Now you often will want to add chart elements, and there's a few places you can add chart elements. You can go up under Chart Tools under the Design tab. There's some quick layout, so we can pick a quick layout here for how we want it set up. There's also in the upper right hand corner of your chart, there's an Add Chart Element button, so you can go ahead and choose what you want. So I could have clicked here on Add Axes Titles and add a chart title. Okay. When I only have one set of data that I've graphed, I usually will not show a legend. If you have 2 or more different sets of data that you're graphing together on a single chart, a legend is useful so you can indicate which one the reader is looking at. So I'm going to take the legend off so we're only looking at just one set of data. Okay. Now you notice we could go to a trend line here later, and I can add the trend line with the chart elements, but I'm going to show you how to add that in a different fashion in a few minutes. Now with my chart title, again, I will have to change my font sizes on all my axes titles and the chart title, so I probably want at least 16 on these font sizes. So you can just click on those text boxes and change the font sizes. Now we'll want to go ahead and add titles here. So for the chart title, I might say this is radiation with distance, or I might be more specific and say that it's radiation in counts per minute with respect to 10 centimeter intervals of distance, something along those lines. But I'm going to put some of that information on my axes titles. So this y-axis will go ahead and have data that is my counts per minute, So I'm going to put for my units CPM, and so whenever I look at your charts, I'm going to make sure that you have correctly entered your units and indicated those. If you do not show your units, there will be a point deduction for that, so make sure you've done that. So here on my x-axis, what you'll want to show is that's my distance from the Geiger counter that I'm measuring, or from the radiation source that I'm measuring with my Geiger counter. So that's my distance in centimeters that I'm looking at here. Okay. Now I have my charted data shown. You want to make sure that your ATSIs, that you have a reasonable scale on your ATSIs. You notice we don't have any data above 1,000 counts per minute, so it's really not very useful to show any information above the 1,000 point when there's no data collected there. So let's go ahead, and I'm going to right click on my ATSIs numbers, and I can go into here and say Format ATSIS. Okay. And as I do so, I should get an option over here on the right, and it will have a minimum, so it started at 0 counts per minute. The maximum is 1,200. I'm going to change that to 1,000. Okay, and so now we can see that it's updated so that my scale is more reasonable. I could click on my x-axis as well and change that scale. We don't have any data past 100, so I might change that to be 100 here. Okay. Now what I want to do next is add a trend line. Now you can either add the trend line under adding chart options from the plus symbol in the upper right hand corner of your chart, or you can go ahead and you can click on one of the data points that you've collected. So I'm going to go ahead and right click on a data point, and I have an option down here on my menu to add a trend line. Okay, so we can add a trend line here. It defaults to linear. We can see a linear fit is not a good choice for this set of data. In your handout for our laboratory, we told you to use a moving average. So you can go ahead and put a moving average in here if you'd like to. Another option that you can use is you might find that exponential will fit quite well with respect to this data. And so let's go ahead and look at exponential, but when you prepare yours, make sure you show me that you can do a moving average as well. You can add two trend lines. If you went back to a data point and clicked on it again, you could add a second trend line, so you could show more than one possible mathematical fit to your data. Now you notice I didn't just connect the dots. We actually used a mathematical function to indicate what's going on with respect to the trend in data rather than connecting the dots. So don't connect the dots with your graphs. Okay, your data points is what I mean by that. Okay, so when I'm looking at this, what we can see is we have a very nice fit mathematically. I'm going to go ahead and, with respect to this, it's kind of hard when you submit this as a file that you send to me. It's hard to see this dotted line. So let's go ahead and edit the trend line. So right now we're under this kind of bar graph icon. If you go over to the paint bucket icon here, you can edit the width of your trend line. And so I'm going to change that width so that it's about 2.5. I think it's much easier to see. And if you wanted to, you could change the colors here with this paint bucket icon, so I could change that color. So if you had more than one trend line, we could go ahead and do that. So let's just say, for argument's sake, that you decided to add a second trend line. So let's go ahead and I right-clicked on a data point. I'm going to go up to my menu to add a trend line, and I'm going to go ahead and say, well, let's go ahead and show the moving average in comparison, since my experiment handout said that I should try to go ahead and try to add a trend line to my graph, to my chart with that. So if I do that, I have a second trend line added, so you can use more than one. Okay, I can go ahead and change the formatting and change it to a 2.5 point font width, and we could change the color to whatever color that we might be interested in using. So now I can have two possible mathematical fits here. Okay, now I could select either trend line that I want to look at. So I could go ahead and go back to my exponential fit, and if you'd like to, you can show a mathematical equation to display the equation that Excel is using to calculate these values for this mathematical fit. So I could click, so you notice I scroll down on the trend line options. I can click on display equation on chart, and again, unfortunately, this version of Excel defaults to a very small font, so let's change that font to something more reasonable so we can see the exponential fit that's being applied with the red trend line that we've put. So what's nice about that is if I was trying to determine the y value for counts per minute for a distance that we didn't actually collect data on, we could put an x in here and calculate y. Okay. It's also acceptable if I don't have you add in the experiment, if I don't ask you to actually determine the mathematical function, you could go ahead and interpolate between the data points by going up here and then seeing what value that would be on the y-axis. Okay, so you can put a straight edge along there. Okay, what you will have to do for some of your PostOp questions is add some information about interpolating between the data points. And so you'd want to go up to Insert, and you could insert let's click off of our function, but we could insert a text box up here. So on the right hand side of the insert tab is a text box. So you could go ahead and say, let's add a text box over here, and say if I was determining at 25 centimeters what my counts would be based on my exponential fit. I might say that it looks as if at 25 centimeters that I would have counts at about 400 counts per minute. So I could go ahead and label that here if I wanted to for a PostOp question. Okay, and I would probably go ahead and click and say, well, this is PostOp question. Let's say if it was PostOp question number 26, I could say question 26 is 400 counts per minute. So I could go ahead and show that in some form. So that's something that you might add potentially. I'm going to go ahead and take this off because that's not actually the answer to question 26. So let's remove that. Now, there will be a question you might be asked. You might be asked to extrapolate information beyond the last data point. So let's say we were asked how many counts per minute were at 110 centimeters. If I want to do that, what's quite nice is we can go out, we can go to our scale, and we can rescale that. So I'm just right-clicking on a number from my x-axis, and I can say Format Axis. I'm going to say, let's go ahead and go out to 110 so I can see that a little better. So I did extend it beyond our last data point, but that's because I am trying to extrapolate information beyond that last point. So what I can do then is go to my trend line. So let's click on the red exponential trend line that I have graphed. Okay, what we're going to go ahead then is scroll down on our Format Trend Line menu here. Remember, that's under the bar graph icon in case you're still under the paint bucket. Okay, what you're going to go ahead then is say, let's forecast forward. So I want to forecast forward with respect to beyond my last data point. So I'm going to forecast forward 10 units. That's going to be the 10 centimeters beyond my last data point. Okay, so now I forecasted beyond, so it's going to help me if I have to extrapolate information beyond there. My mathematical function would also be useful for that as well if I was trying to calculate it from that function. You'll notice there's a display r-squared value on the chart as well. If you want to, you can go ahead and click on that, and that kind of shows how good of a fit we have with our mathematical equation. So the closer you are to 1 with your r-squared value, the better your mathematical function, the exponential here, fits the data you've collected. So if you get a value close to 1, then it's a good fit. If you start getting a value that's less than 0.9, or if it's 0.8 or lower, the fit starts to be more and more questionable, and you might be able to come up with a better mathematical function for a fit to that information. Okay, so those are some common things you'll do when you're graphing. Okay, if you have questions, contact me. I'd be glad to answer them. Okay, have a great day, everybody.